What's up everyone, welcome back. So in this video we're going to be making our application to adapt to a persistent database. In the previous video we looked at how we could build a simple functional CRUD API using an in-memory database, and that database was represented by a Python list. In real-world applications it is very essential that we use a persistent database solution. Now, FastAPI supports various types of databases. If you want to use a relational database or if you want to use a non-relational database, the choice is yours. For this series, we're going to be focusing on using a relational database, specifically PostgreSQL. PostgreSQL is a widely used free and open source relational database management system that comes with a lot of benefits, of which if I began describing them in this video, we will be wasting a lot of time. While using Postgres, we also need an object relational mapper, which is just a way for us to interact with a database using our Python programming language. An object relational mapper is simply a translator between our programming language, which is Python in this case, and the database, that is a relational database such as PostgreSQL, MySQL, SQLite, and so on. An ORM works in the following way. It maps objects to tables. When you create a Python class, that Python class is going to represent a certain table in our database. And each object we create of that class is going to correspond to a row or a record of data within our database. Secondly, it interacts with the data. For example, whenever we create an object of a class that is created from an ORM, we can interact with this as a Python object. And we can call things such as methods and define attributes on that specific object, just like we're going to see. Behind the scenes, an ORM also performs operations on objects like saving them, deleting them, updating them, just like we did for the CRUD. These ORM operations are translated into the appropriate SQL queries that the database understands. So whenever we use an ORM and carry out CRUD, in the background, the ORM is performing all the necessary SQL without us having to worry about it. The ORM also handles converting Python data types into database-specific types and vice versa. So for example, if we are having datetime objects in Python, those datetime objects will be converted into datetime objects that the database is going to understand, and so on. SQLAlchemy is the most popular ORM solution for Python that helps us to map objects to tables, and it also provides an SQL toolkit that allows us to write high-level Python to represent SQL statements. However, despite the fact that SQLAlchemy is powerful, using it with FastAPI is going to be complex, and there's where SQLModel comes into the picture. SQLModel is an ORM that enables us to use the power of SQLAlchemy as well as the power of Pydantic. So much as we may write our models in a class object-oriented manner, those models are also Pydantic models, and therefore they can be used for both data validation as well as our database operations. Now, this project was also created by the creator of FastAPI, and meaning that this was motivated by someone who saw the need to have SQLAlchemy integrated into Pydantic to create the best ORM for FastAPI. Now, without further ado, let us get into setting up our SQL model and looking at how we can use it for our database solution. Now, in conclusion, an ORM is going to simplify the interactions by letting us developers use Python instead of SQL. The first thing we're going to do is to first of all set up a database that we're going to be working with. We have chosen PostgreSQL, and depending on which system you're using, the process of installing PostgreSQL is going to be different and is going to involve a number of steps. I already have PostgreSQL installed on my machine, but I'm going to be showing you one of the ways in which you can get a free PostgreSQL database. I'm not sponsored in this video, but this can help you to get a free PostgreSQL database that can help you work with PostgreSQL just in case you need it. And that's where Neon comes in. So when you go to the Neon website, you can create an account, and right here in your Neon console, all you need to do is just create a project. So we shall call this Bookly, And once we've been able to do that, we shall create a database name, and this is going to be our Berkeley DB. Now I'm not going to be using this, I'm just showing you how to set it up. So we shall go ahead and create a project, and once you've created the project, you're just simply going to go ahead and get a database URL that you can simply copy into your settings, and then you'll be able to use that. But for my case, I'm going to be using PostgreSQL on my local machine. So to do that, I'm going to run the PSQL shell, and right in there, I can access it via the user. And once I've been able to access my PSQL shell, I'm going to go ahead and simply create a database. So to create a database, I'm going to go ahead and say create database. This is a simple SQL statement, and then I'm just simply going to call it Berkeley _ DB. And that will just be able to create the database. Now for us to formulate the SQL or the PostgreSQL URL to this database, all I'm going to do is to go right inside our code right here, and I'm going to introduce a new file, and I'm going to call that file .env. So .env is going to be the file in which we're going to create all settings for our project. These settings are going to be kept secret and are not going to be kept in our version control. And this is going to be important in a way that in case we are to share this project with other people, or in case this code is to be accessed by anyone, they will not be able to get these secrets, such as our database keys or our secret keys and so on. So to begin, I'm going to create a file, and I'll call it .env. Mind that I've kept it in the root project folder right here. Another thing I'm going to do is to go ahead and set up an environment variable to stand to the URL of our PostgreSQL. Now in your case, it's going to be this neon URL right here, but for my case, it's going to be something on localhost. Another thing I'm going to be doing is to use an Asyncpg API. So I'm going to be using PostgreSQL with an asynchronous DB driver or a DB API. So a DB API is just one way in which Python allows us to access a database. So let us begin by installing that DB driver. So I'm going to go to our Python right here, or our terminal in my virtual environment, and I'll begin by installing it with pip install, and this is going to be our Asyncpg. Once we've installed Asyncpg, now let's go ahead and formulate our PostgreSQL URL. So I'm going to create a database URL environment variable, and this is going to be database URL. Now remember, we are working on localhost for my case, but you already have one you've got from Neon. So what I'm going to do is to formulate this as, I'm going to start by mentioning the kind of database that we're going to be using, which is going to be our PostgreSQL plus the DB API or the driver that you're going to be using. So in this case, we are going to be using Asyncpg, and then we shall need the user of that specific database. So my user is going to be JOD35, and then the password of that user. Now this is not going to be your password, so please use your own password. So I'm going to provide my password right here, and once I provided my password, then the host is going to be localhost, and the port is going to be 5432. Then slash the name of the database, which we have called Berkeley DB. So once that is done and you've got your PostgreSQL URL, then the next thing is going to be for us to access this so that we can use it within our code. So there are very many ways in which you can manage environment variables, but to be specific to FastAPI, we shall use Pydantic Settings, which is just a tool or a library built on top of Pydantic to give us the ability to manage our environment variables. So to do that, I'm going to go right in here in our terminal, and then I'll say pip install Pydantic -settings. So this will collect Pydantic Settings and install it within our virtual environment. So I'm going to go ahead and set it up so that we can read our environment variables. So to begin, we're going to go within our source folder right here, and we're going to create a new file at the root of that folder, we're going to call that module config.py. Inside config, we are going to create the class that's going to be responsible for allowing us to read our environment variables. And for us to do that, we are going to make use of a special class from Pydantic Settings, and that is going to be our base settings class. So to begin, we're going to import that. We're going to say from Pydantic Settings, we are going to get access to the settings class, or the base settings class, sorry for that. And once we've been able to do that, then let's create our class, and this class is going to be called our settings class. This class is going to inherit from our base settings, and once we've been able to do that, all we shall have to do is to just go ahead and get the exact key as we've written it in here, and then have it as the attribute of this class. So what this will do is to automatically go ahead and read each key we've defined here, and then have its value accessed via this class, just like we're going to look at it. So right after doing that, then the next thing is going to be for us to specify the right type of that specific value of that specific key. Now for us to do that, we're going to go ahead and specify that this is going to be a string. So this is just enough for us to read our database URL. But the problem is we haven't yet told Pydantic Settings where it's going to get these settings from. To do that, we're going to be making use of another class which is called a settings config dict, or the settings config dictionary. So we're going to go ahead and import that. So I'll come right here and say import the settings config dict. Now, to influence any Pydantic model, because this is actually a Pydantic model that we have right here, we are always going to make use of the model config attribute. So every class that is a Pydantic model is going to have a model config attribute, and this is going to be a dictionary that will allow us to change the configurations of a specific Pydantic model. Now for us to do that, we're going to set its value to our settings config dict, and in this case, this settings config dict is going to be helping us to point to where our env file is, or where to read our settings from. So even if we go right in here, we can look at some of the attributes it has. It has the env prefix. In case you have an env prefix, you can specify one right here. Just in case you have an env file you're reading from, you go ahead and do that from here. If you're reading from, let's say, a JSON file, a YAML file, it does all of that. But for our case, we're going to be using an env file. We can also specify an env encoding in case we are to have one, but we're going to just keep it simple. One other important attribute we're going to provide here is the extra attribute, and in this case we're going to be ignoring any extra attributes that will be read from our class. So to do that, we're going to go in here, and the first thing we're going to do is to specify that our env file is going to be equal to .env. So this will go ahead and read the .env file that we've created and provided our database URL in. So let us go ahead and do another setting. So once we've been able to do that, then let's go ahead and also add one extra attribute, which is going to be our extra. So in this case, we have extra equals to ignore. So we can allow reading other extra attributes, we can forbid them, but we're going to specify that we are going to ignore any extra attributes from being read. So we shall define every key that we shall get from our env file into our class so that we can access it within our application. So let us go ahead and test the working of this settings class. Now what I'm going to do is to go ahead and open up my terminal. So I'll come right here and say Python 3. And once I've been able to do that, let me make this a little bigger so that you guys can see. We're going to begin by accessing this class we've got right here. So we're going to say from source.config, because that's where we've created the settings class. Shall go ahead and import our settings class. And once we've been able to import that settings class, we're going to create an object of that class. So let's just call it S. And that is going to be our settings object. So once we've been able to access our settings object, let us try to access our environment variable from this object. So we shall say database URL, just like we called it right here. And once we do that, then we can successfully access that specific environment variable from our env file. Now keep in mind that this is a file that we're not going to share with anyone. We're going to add it to the .gitignore file so that we do not commit it to version control. So I'll just do that right here. I'll say .env so that whenever we add this code to our Git repository, that file is not tracked. Now, away from that, once that is done, now let us look at how we can connect to our database using our SQL model. So to begin, let us go ahead and install SQL model. So I'm going to exit this shell and then I'll close this. So I'll begin by installing SQL model with pip install and then SQL model. So this will go ahead and collect SQL model, add it to our virtual environment. So just like you see, it depends on SQLAlchemy and also SQL model. It depends on also Pydantic, and yeah, that's how we've been able to install our SQL model. So once we've been able to install SQL model, let us go in our source folder and create a new package. So this is going to be called our DB. And this is also going to be a Python package, just like we have the other packages. So inside here is where we're going to do everything that's specific to our database. By that, I mean anything concerned with creating sessions and also helping us to connect to our database. All that code is going to be found within this package. Now let us go ahead and create a new file, and that file is going to be main.py. So inside main.py is where we're going to create our engine object. Now if you've worked with SQLAlchemy, you will know that an engine is the basis on which you do everything from connecting to your database to carrying out any sort of CRUD. So SQL model also relies on that because it's based on SQLAlchemy. Therefore, we need to first create an engine. Now, keep in mind that we are using an Asyncpg API, and therefore, we need to create an async engine. So let us look at how we do that. So I'm going to go ahead and import the create engine function from SQL model. Now, these are all borrowed from SQLAlchemy. Therefore, I'll just come and say from SQL model, we are going to go ahead and access the create engine function. But this is going to be creating an async engine. So for us to create the async engine, why not use the async engine class from SQLAlchemy? So we're going to begin by importing that. So we shall say from SQLAlchemy.ext.asyncIO, we shall go ahead and import our async engine class. So let us go ahead and create our engine. So our engine is going to be equal to create engine, and this is going to take in our database URL and other attributes. So let's go ahead and create that settings object. So I'm just simply going to come right here. I'll create a config object. Now keep in mind that I've kept it like config just for syntax. You can call it whatever you want, but as long as you're going to remember what you've called it. Now I'm just simply going to say this is going to be settings and to be an object of type settings. So it's going to be an object of our settings class. Now we're going to be importing this every time we shall need to access an environment variable. So whenever you create an environment variable, you go ahead and add it within your env file. And once you've added it there, then you'll add it as a field to the config class. And then after adding it as a config class, then you access it via the config object that we've created right here. So let's go ahead and access that object. So I'll begin by importing it. I'll say from source.config, we are going to go ahead and import our config object. Now let's go ahead and set up our URL. So our URL in this case is going to be our config object. And once you've been able to do that, now we're also going to set equal to true. Now remember, when using the create engine function, the echo attribute is what allows us to see all the SQL that will be logged on every transaction that we carry out in our database. So I'll come right here and say echo is going to be equal to true. And just like that, we've created a basic engine object. Now to make this an async engine object, we're going to begin by, first of all, making it an instance of the async engine class. So for us to begin, I'm going to go ahead and just simply Sorry for this. So I'm just going to come right here. Actually, I've made a mistake here. This is supposed to be the database URL. So I'll say config.database URL, and that will mark it as our database URL. Now let me go ahead and also change this from our basic engine object to an async object. So I'll just simply create an async engine object, and then I'll simply provide our engine. So this will create it as our async engine. All right, with that out of the way, now let us look at how we can connect to our database. Now, when is the right time to connect to a database? The right time to connect to a database is when the application is starting. So how can we make a task run at the start of our application? FastAPI allows us to do this in a very interesting way. And this is through lifespan events. So a lifespan event is something that you may want to run through the lifespan of an application. Now, this may involve something that you may not want to do or load during the lifetime of an application. An example can be running a machine learning model. This can be something that can be expensive, something that you cannot run at the start of your application. However, it may make more sense for you to start running your machine learning application just at the start of your app. And whenever that application is running, that AI model or whatever you're running is going to be running. So let us look at how we can set that up. To begin, we're going to go to where we created our FastAPI instance, and we shall go ahead and simply set that functionality to work. Now, is our server running? Yeah, our server is running right here. So I think I'll go ahead and stop it with Control and C, and then I'll close the terminal that we have right here. So each FastAPI instance is going to come with a special attribute called the lifespan attribute, and that is going to take in the code that we want to run at the start and at the stopping of our server. So let us create our first lifespan event. To create a lifespan event, we are going to be making use of a specific decorator that comes from the context-lib Python inbuilt Python library. So we're going to do that by first of all going to the top of our code right here and saying from context-lib, we are going to go ahead and import a special decorator called the async context manager. And once we've created that, now we're going to determine which code is going to run at the start of our application and which code is going to run at the end of our application. So to do that, we're going to go right here and say at async context manager, and then we're going to define a coroutine that is going to run throughout the lifespan of our application. So we're going to define this as our lifespan, and this is going to be a function called lifespan, but it's going to take in one important attribute, which is going to be an app instance. So this is going to be of type FastAPI. Now, once we've been able to do that, it's time for us to determine which code is going to run at the start of our app and which code is going to run at the end of our app. So to do that, we're going to first of all write two print statements. One is going to run at the start of our application, and another one is going to run when we stop our server. So let us go ahead and do this. We shall say print server is starting. And once that is done, then we're going to also print server has been stopped. So once we've been able to do this, we have two print statements, one indicating that the server has been started and another one indicating that the server has been stopped. How can we separate these two to make them not run at the same time? Or how can we make this run in an order where the first one is running at the start of our server and the second one is running at the stopping of our server, or when we stop our server? So this is where the yield is going to come in. So for us to do that, we're just simply going to introduce the yield word right here. And this keyword is going to determine which code is going to run first and which code is going to run at the end of our application. So just have this in mind. You don't have to memorize it. The moment you define your lifespan event and decorate it with the async context manager, the code that's going to run at the top of the yield statement is the one that shall start at the server, and then the one that will run after your yield statement right here is one that's going to run when our server stops. So when we have defined our lifespan event, we also have to go ahead and sort of register it to our FastAPI instance. And the way we do that is by coming to the FastAPI instance that we created right here, and then we can simply go ahead and say lifespan, and then we point to that specific lifespan event we've created right here. So that's going to be equal to lifespan. So to test the working of this, the first thing we're going to do is to go ahead and run our server. So we're going to pull up our server with FastAPI dev and then our source folder. Now, one thing we are noticing is we are getting this error right here that is telling us that our generator object is not an async iterator. So let's go ahead and fix this. So when we take a look at our lifespan event right here, it seems like we have to define it as an async function, and that is not something that I have done or something that I have forgotten. So what I'm going to do is to introduce it. I'll come right here and say async def and then lifespan. So this is going to go ahead and run our server is starting print statement, just like you see right here. So if we press Ctrl and C, we're going to notice that server has been stopped, is going to be run. So just like that, we've been able to set up a lifespan event. Now let us look at how we can create a database connection at the start of our server. So I'm going to go back to our main.py where we created our engine object. And the first thing we're going to do is to create sort of like a function that we're going to run at the start of our application to help us to create a database connection. So I'm going to come right here, and what I'm going to do is to create an async function, and I'm going to call this async function initDB. So this initDB function is going to be one that's going to allow us to create a connection to our database and keep that connection for as long as our application is running. So I'm going to start by using our async, or by using our engine object that we've created right here. So I'm going to create an async with statement, and what this is going to do is to help us to create a connection object, and then we shall carry out a simple SQL statement on our database. Now let us get started by doing async with, and inside here we're going to begin by creating our engine object. So we're going to call that engine.begin method, and once we call that engine.begin method, we are going to access the connection object via that method. So now that we've created our connection, let us go ahead and create our statement that we're going to execute on our simple database. So to do that, we're going to create a variable called statement, and statement is going to be equal to a simple select statement. But for us to carry out a statement, we are going to need to express this in terms of text. So SQLModel provides a text function that can be used to turn a text or a string SQL statement into an actual SQL statement that we can then use our connection to run on our database. So we're going to begin by going ahead and importing it. So I'm just going to go at the top right here and import the text function. Then I'm going to come right here and say text, and then we shall run our simple SQL. So just like you see right here, we're going to create an expression representing a textual SQL string. So we shall just come right here and say select, and all we want to do is to select the word hello, or to run the word hello on our database. So this is going to be executed as an SQL statement. So we're going to close this, and once you've been able to do that, now let's go ahead and run this using our connection object. So to run our statement using our SQL, we're going to create a result object, and this result object is going to be a result of using our connection to run that statement. So you're going to say con.execute And in this case, we shall provide the statement that we are trying to run on our database. So this is going to be our statement, just like you see right here. And once we need to access all the results, we are simply going to go ahead and run result.all. And this is going to be able to run our select statement. So let us go ahead and run this. So to begin, I'm going to go right where we have our lifespan event, and instead of having to run the print statements, I'm going to go ahead and run this initDB function that we've created right here. So I'm going to go at the top right here, and I'll begin by importing that. So I'll say from source.db.main, we are going to access our initDB function. And once we've been able to do that, now let's go ahead and run this. So I'll call initDB, or let me go ahead and run it after the server is starting statement. Now keep in mind that initDB is a coroutine, and therefore if we need to run it, we need to call it with await. So whenever you define an async function, for you to be able to call it, you have to call it with await. So we're going to go ahead and save and rerun our server with FastAPI dev and then source. And now we shall see what is going to happen. So when we run our server, notice what is going to happen. Since we set echo to true, we are going to notice that some SQL is going to be executed and it's going to be logged within our console. So right here we see that the select statement has been run, which is select hello, and the output of that has been printed right here. So we have a list, but that list has a result that is our hello that we've selected on top of our database. So this shows that we have been successful in connecting to our PostgreSQL database. Now that we've been able to do that, let us go ahead and create a database model for our book data. Once we've created that model, we are now going to go ahead and create, read, update, and delete book objects in a real persistent PostgreSQL database. So to do that, we are now going to go ahead and inside our books module or books package, we're going to create a new file and we're going to call that models.py. So models.py is going to be the special file in which we're going to have a database model for a specific entity. If we have, let's say, the user model, we shall have that located in its package and then models.py. If we have reviews model, then we have that in reviews/models.py, just like we're going to see. Now let us begin by creating our simple model. So our model is going to be very similar to what we have inside our schema for books. However, we're going to add on some extra fields, just like we're going to see. In fact, let me go ahead and just copy what we have here, and then I'll paste it within our models.py. So you're also going to notice that a Pydantic model is actually going to be very similar to an SQL model. In fact, we're going to get rid of this and we shall only be using our model. So I'll go back to models right here. So I'll begin by first of all pasting it right here. And instead of base model, in this case, I'm going to be using the SQL model class. So for us to create a Pydantic model or an SQL model, actually, we have to go ahead and import our SQL model class. So we shall say from SQL model, but we don't have it installed, so you have to go ahead and do that. So I'll open up my terminal within our virtual environment, and then we shall say from, this is actually going to be pip install SQL model. Seems like we installed it already, so I'll go ahead and use it. So I'll say from SQL model. I wonder why I forgot that I installed it. So we shall say from SQL model, we're going to go ahead and import our SQL model class. Now I'm calling this SQL, but you can call it SQL or anything you want. I hope that doesn't irritate you. So once you've created this book model, we're now going to go ahead and subclass the SQL model. But for us to make this a table class, then we're going to also provide one important argument that's going to be the table argument. So we're going to go in here and then we shall say that table is going to be equal to true. So once that is done, we have our fields, but we're going to also introduce two timestamps that are going to be for the created at date as well as the updated at date. So I'm going to come right here and say that this is going to be created at, and then we shall have this being a datetime object. So I'll go ahead and import the datetime class. So I'll say from datetime, we are going to go ahead and import our datetime object. So once that is done, then let's annotate that with the type of datetime, and also do the same thing for the updated at time. So the updated at date time is going to be equal to that. All right, another thing we're going to do is to change our database model so that instead of having an ID that is an integer, we actually have a unique identifier or a UUID. And this unique identifier is going to be one that's going to be unique to any object that we shall ever create in our database. So for us to do that, we're going to be making use of Pydantic's field function. And what this does is to allow us to define extra attributes that may belong to a specific field on a Pydantic model. Using that, we can also go ahead and specify the database types or the SQLAlchemy database types for a specific field. Now let's say you wanted to customize a field so that it has PostgreSQL specific types, then that is what we're going to be using. Now, databases such as SQLite may not have the support for UUIDs, but when using PostgreSQL or MySQL, you can be able to use the UUID type. So let us go ahead and set that up. We're going to begin with the ID field, or what we have as our ID field. So I'm going to begin by changing it from ID to UUID. And then instead of integer, I am going to set this up to be using the UUID type. So the UUID type is present within the UUID module that's present within Python. So I'll go ahead and import that. I'll say from UUID, we are going to be making use of our UUID class. And once we have that, then we are going to go ahead and say this is going to be our UUID. Another thing we can do is to just simply import UUID, or what I can actually do is to just say import UUID, so that I can easily access everything of the UUID module. Now, once this is done, we need to go ahead and specify the exact way we want to store our UUIDs. So I begin by importing the field function. I'll go at the top right here and say from SQLModel, we're going to import field. And once we've been able to import that, then this is going to be a Pydantic field. And this is going to also have the SQLAlchemy column. Why? Because we are going to be accessing the specific UUID type for PostgreSQL, and that's what we want to store our UUIDs with. So for us to use SQLAlchemy column types or specific attributes and stuff, all we're going to do is to access the SA column attribute, and then we are going to define this field as though we were defining an SQLAlchemy field. So to begin, we're going to make sure we get access to the column class, and with that column class, we're going to define whatever we want to define on this specific module. So we're going to come right here and say that we need to get the column class. So once we've imported the column class, we're going to define this as a column, and then this column is going to take in the type of that specific field. So we need to first of all go ahead and import it, and this is going to be the PostgreSQL UUID type. So I'll come and import the dialect for PostgreSQL that's going to allow us to access all the field types as they are on our PostgreSQL database. So I'll say import SQLAlchemy. So sorry for this. So this is going to be import SQLAlchemy.dialects.PostgreSQL. So you can also access other dialects right here. You have those for PostgreSQL, MySQL, Oracle, and SQLite. But in this case, we are using PostgreSQL, so I'm going to go ahead and say PostgreSQL, and want to go ahead and import it as PG. So we're going to be accessing everything via PG. So This is going to be import as PG. I think I've made a mistake right here, so it's going to be as PG. Now, once we've been able to do this, let's go ahead and set our type up. So we're going to provide our type in here as our PG dot UUID. And once that is done, let's define other constraints. So we can say this is not going to be nullable, so we can say nullable equals to false. And then we can also do other things such as setting the primary key attribute. So we can say that our primary key is going to be equal to true. And we can also say that this is going to have a default. So we can set the default by using this column class. So we can say that this is going to have a default, but our default is going to be a newly generated UUID. For us to generate a new UUID, all we have to do is to call a UUID function, or call functions that create specific types of UUIDs. So I'll say default is going to be UUID dot, and in this case we shall call a function UUID4. So we need to create a UUID4 type of UUID, and this is going to be enough for us to define our primary key column. Now another thing we're going to do is to define the table name of this class, and the way we do that is by using SQL Alchemy's table name attributes. So we're going to come right here and say that our table name is going to be equal to books, and that is going to be just enough for us to set the table name of that specific table. So the rest of this can also be set up, but I'm going to simply leave them out, except for the created at and the updated at timestamps. I'm going to define them as timestamps from the PostgreSQL dialect. So I'll just go ahead and define them as what we've done for this. I'm going to do that by saying this is going to be equal to field, and the field is going to be, so right in here, we're going to come and say that our field is going to be a column, and this column is going to be of type pg.timestamp, and then right in there we are going to also go ahead and set up the default. So I'm going to say that the default is going to be equal to, so in this case we shall just say date time dot now, and I'll do the same thing for the updated at. So I'll just come right here, or let me just actually leave it to this, but let me just leave it to default equals to updated at, which is now. So we shall also look at how we can set this when updating each of the book objects. So once we've been able to define this object, now we can also define a method on this class that's going to be responsible for giving us a string representation of the book object we've stored in our database. Now for us to do that, we are going to go ahead and say def, and this is going to be our danda repre, and this shall take in self. Now what this is going to do is to return an object of type book, but it's going to return it in a very readable format. So we shall say book, and in this case we shall return self.title, which is the title of that specific book that we shall be accessing at a given point. All right, we've been able to create our database model. Now we need a way for us to create this in our database, and we're going to achieve this using our lifespan event that we created in the previous sections. And this is going to be very easy because all we're going to do is to be using the metadata that's going to be present on our SQL model. So the metadata is simply the data about the database, and once we define any class with the SQL model, we get access to the metadata present on our SQL model class, and whatever class is defined there is going to be created by calling a specific method called the createAll method. So once we've been able to do that, our database tables will be created in our database, and we shall now be able to go ahead and run our CRUD just like we did in the previous video. Now to do that, we're going to go within our main.py, and we're going to modify our initDB function so that it actually goes ahead and creates our database. Now, for us to do this, we're going to come right in here and remove what we have. And instead of running a simple SQL statement on our database, we are now going to go ahead and create database tables in our database. So to begin, we're going to have to first of all import the model that we've created inside our models folder or our models module right here. So I'm going to go ahead and access that. I'll come at the top of our code and say from, it's going to be source.books.models. We are going to go ahead and import our book model, or we can actually also import it from here. And once we've been able to import it from there, then we're going to go ahead and call the SQLModel class. And to do that, we're going to have to go ahead and import it. So we shall say from SQLModel, which is actually already imported at the top, we shall import our SQLModel class. And once we've been able to import our SQLModel class, now let's go ahead and call a specific method that's going to be the one to help us to run synchronous code with our connection object. Now, that special method is going to be the con.runSync method, and that is going to be running any synchronous function within this context that is async. So shall come and say that this is going to be a wait, and in this case we shall run con, which is our connection object, dot run sync, which is run synchronous or run any synchronous code. And in this case, what we want to do is to access the metadata object on top of this SQL model. So we shall say SQL model dot, and we shall get access to the metadata object. Then on that, we can call create all, and that is one that's going to run our create all statement. So this is going to scan for any models that have created, any models that have been created using this SQL model object, and to access the metadata, and using that metadata it will go ahead and create these tables in our database. So when we save and go back to our server, we're now going to notice that our server is going to restart, and by restarting it is now going to call this method right here, and all the SQL that has taken place is going to be working fine. So we're going to have our create table books, and this is going to create the different fields that we have on our database, or the ones that we've defined within our model that we have right here. So just like that, we've been able to successfully create our database table. Now let us go ahead and confirm if our table has been created. Now if you're using Neon, it has a very nice user interface that can allow you to see your database table, but I'm going to be digging into the shell and then inspecting the table that has been created within our database. So to do that, I'm going to go back to my terminal right here, and then I'll connect to that specific DB, which is our Bookly DB. And once I've connected to it, now I'm going to go ahead and list the tables that are present on that specific database, of which I have only one, which is our books database. And once I have that, then I'm going to go ahead and describe it. So I'll say D and then books, and that is going to show us the structure of our book database. So we've created the UUID, which is a UUID type, just like you see right here. Author is a string, publisher is character varying, publish date character varying, of which this can also be set to a date. Now I think I'm going to fix this. And also we can have our page count, our language, created at, updated at, and also our indices. So we have the primary key being set to the UUID, just like you see right here. So in this video, we've been able to create our database using PostgreSQL and SQLModel. I hope you've learned from this video, and if you've done so, please leave a like on this video. Do not forget to share this video with whom it may be helpful. And I hope you've learned from this video. If you have any comments about what you've learned from this video, please go down in the comment section and leave your feedback on this video. In the coming video, we're going to be building on top of what we have for now, and then carrying out the CRUD just like we did for the previous videos. Thank you guys for watching, and I'll see you in the next video. Bye.